Hello, what is going on? This, this is, this is not a test. I'm about to rock it. All right. Let's say DOS EMU, bang. And today we're gonna talk about some jumps. Believe it or not, I'm making all these videos in succession, and there is no today for me. It's not like these are all created like a day apart. It's all like a freaking 6-hour sleepover, coffee, cigarette day for me. Why? Because it's dark outside. I think we have the grayest winter since the beginning of time. It's really depressing outside. It's always raining, always cold. Alright. That's because I'm in New Jersey. Let's say this. Let's say debug, and we'll say dump. Okay. What I'm going to do today, I would like to talk about more of what we did on the last tutorial about jumps. And this time I'm going to show you how to do a test statement. We're going to be using some stuff like some syntax like jump not equal, jump equal, and compare. The compare statement. And we'll look into what that does. Okay? Super. Let's rock it. Exit, clear. Right? Let's say debug. First we want to set our assembler to address 100. Right? Right. Now, as I said before, we want to first jump in, and then we want to kind of jump out, right? We're going to jump to address, let's say 120, okay? And at address 120, well, on this line here, we'll jump back to address 120 in a second, but here we want to define some bytes, okay? And let's say something like, we'll ask a question. Do you, I need to not make it so long, or I'm going to have, do you like tacos, okay? We'll ask that, okay? And that's the end of our string, and we want to put it on a new line. Well, actually, let's see something here. Let's see something here. What we want to do is we want to put one of those funky boxes, right? One of those yes, no boxes. Okay? So that's what we'll do. We'll put it there, and we'll encapsulate that. Should we put on a new line? Let's see what happens if we don't put on a new line. Why not? Okay? But we do want to kill it with the string terminator. Okay? Let's do just that and enter. Okay? Now we need to go back in assembler mode, and we need to set our new address to 120. Okay? We jumped over our data. Okay? When this executes, this is going to jump right over our defined bytes, but the defined bytes are already there, so you have a place in memory. Okay, so this address does exist for us, okay, that we can call on later. Okay, but we jumped 120. Now let's assemble at 120. Okay, and we're going to throw in a second string. Let's say define bytes. We're going to say me too gangsta. Okay, exclamation point. Alright, now we're going to use the $ string terminator, which is the same in hexadecimal as 24. Okay, and that's what we're going to do. This $, we could encapsulate this and throw the $, but we have to encapsulate the $, after we throw it too. Okay, so let's do that. And that's at 120. Actually, I'm lying to you. Don't put that in. Do this first. We jumped at 120, and I'll show you better. We jumped at 120, now let's jump to 140. Okay? Okay. So now let's put in our defined bytes, and we'll say, me too, baby gangsta. Gangsta. Rolling hardcore with the homies. Alright? Let's do that. Okay. Comma, space, encapsulate this string terminator. Okay? I like that. I feel confident. I will enter this. Okay? Now let's take our assembler and we need to move it up to 140. Okay? And at 140 now we're going to jump again with a third string, but we're going to jump, let's say, to 160. Okay? Okay. And now we're going to jump over our defined bytes, alright, but these defined bytes will have a place in memory, and we'll have another statement. So if you say yes, it's going to say me too, baby gangster. Rolling hardcore, homie, the top down. And if you say no, it's going to say, you're lying. Alright? No, let's make it say something better, like, you're, I mean, who does not like tacos, right? You gotta be insane not to like tacos. You're crazy. I dropped the F-bomb in the last video, and I want to do it again. You're crazy. Alright? Now let's take it, and we're going to encapsulate it in here. Okay? And that's that. So, I feel confident. Let's, actually, I don't feel confident. And what I should have did was put on a new line. Okay? I should have put it on a new line, and I can do that right now. But I'm not going to be able to show you the dexterity of the, what do you call it? The dollar sign. So let's say OD, comma, space, OA. Okay? Comma, space, and then encapsulate our dollar sign string terminator. Okay? So that's what's going to happen there. Now I feel confident about this. Let's enter it. Okay. So now we jump. We're going to jump right to address 160. At address 160, let's say something like address 160. Okay. Let us then begin our code. Okay. Now I'm going to pause here really quick. Well, I'm going to say move first. Okay. I'm going to pause here really quick, and what I'm going to do is I'm going to scribe down these memory locations. Okay. I'm going to put these down. I don't believe in writing on paper because I have a computer. Alright? But I do want to show you that if you don't write this stuff down, it will disappear, and you'll have a heck of a problem finding it again. And you'll be like, oh my god, my life is so hard. Alright? And it's not the case. Whoa! Give me back my stuff. Alright. Let's open up a new terminal. Okay? Actually, you know what? We can be cool and just minimize that. Alright? And we're going to do this. Okay? And we'll do something like this. Let's bloat it. Okay? Let's put in a new line. Alright. So we're going to say, address, bang. Okay? And we're going to say, do you like tacos? Okay? Yeah or no? We want to put that at address 102. Bang. Okay? And that'll work for us now. Okay? Clear. What happened? Oh god. Let's do it again. Okay? At, we'll say 102. Okay? We're gonna say, do you like tacos? Okay? And then at address, at address 122, we had a second statement. Alright? That second statement, if it was yes, it was gonna say 122. It's gonna say, me too. Alright? And then we had another statement loaded at 142. Okay? And that was the no statement. Okay? and we'll say 142 contains the address of you're crazy. You're crazy. You're crazy. Okay? So that's that. Now that's our little thing there. Okay? Now let's move this out of the way. We can even make this full screen again. Alright? Now we have our data logged. You know what I mean? So, because this stuff will disappear. Alright? Super. Okay. So now back into where we were. And like I said in the last video, our assembler starts at 100 and immediately jumps over to 120, skipping this data bytes here, okay? But these data bytes still have a place in memory, and so they are really logged, okay? So you see it jumps over 120, and then this moves the assembler up to 120, right? As soon as the assembler hits 120 and the code starts reading again, it says jump to 140, okay? So it jumps right over this, and this still holds a place in memory, okay? And then we move our assembler up to 140, okay? And as soon as we hit 140 and the code begins to run again, it just jumps right over our other defined bytes, okay? So that's what that does. Now we move to address 160. We've got nothing else to say. Let's put in some code. We're going to move into AH register 09 or prepare for string, okay? That is that. Okay, enter. Our next command instruction will be, now we'll move into the DX register. Move into DX register the question, or the entry in question, okay, or the beginning thing, or we're going to move into it. Do you like tacos? Tacos is located at address 102. Okay, so we're going to move into the DX register the address 102. Okay, enter. And now we're going to say execute this. Okay, this is going to execute. It's going to ask us the question. Okay, now we need to get data. We need to read key input. Okay, we need to get user input, or we need to get key press, or we need to get from the keyboard right now. Okay, so in order to do that, we're going to say move into AH. Okay, this opcode here, this opcode 01 gets the user input. Okay, it gets the user input and shows the key press. Okay, unlike this opcode 08, I believe, I could be wrong, but I think I'm pretty right, it gets the user input and hides the key press. Okay, maybe it's 02, I don't know. Alright, but we will find out, because I did find out, and we will show it. Alright, but for this right here, this takes the user input that it gets from the keyboard and it puts it back onto the, or it displays what key you pressed onto the screen. Okay, so that's what we want to do. Move into AH the opcode of 01. Alright, if you notice too, like I said, our opcodes are sticking in one register, and that's the accumulator register. Alright, that's where opcodes go. Okay, I don't think you can put them anywhere else, but that's where they say they should go. So they should go there. Enter. Okay, now let's initialize that. Int does not stand for initialize, it stands for interrupt. But let's execute that bit that we had there. Okay? Okay. Now what we want to do is use something called a compare statement. Okay? Now, this key press gets stored or showed. This key press gets showed, but at the same time, we got user input. Okay? And this is where my rant and previous stuff is important. We moved our string into our, we moved our opcode for string into the AH register. Okay, then we moved the address of the string in. Okay, then what we did was we executed that, or in this sense we put to screen. Okay, or it dumped out DX. Okay, so now we have, what we should have is, do you like tacos, yes or no? Okay, now we moved in to the AH register a key press. This gets user input and shows user input, shows the key press. Okay, and not only gets it, but it shows it. Okay, but when this gets, it's got to go somewhere. Okay, and this is where the handler comes into play. Okay, and maybe we'll execute it on a T and show exactly what happens. But we then want to execute that. Okay, and the handler, what happens is we move this opcode into the AH register, but the AH register, or the opcode, sends back something called a handler, alright, and sets flags or something, but sends back something called a handler, and that handler gets stored in a certain location, and where it gets stored at is going to be in the AL register. Okay, a low. That's where our handler is going to come back to us. Alright, now what we want to do is we want to test what is inside of AL with yes or no. Well, obviously we cannot just type in yes, and we cannot just type in no. Alright? Well, that's not obvious either. But we can't type in yes and we can't type in no. Why? Because whatever we put in is an ASCII, right? Well, we have to test what is inside of the AL register, or the value stored in there. We have to test what's in there, what the key press was that we initially pressed, with the hexadecimal representation of Y or no. Okay? Okay. So, what do we want it to say? We want it to say yes. Why? Let's go pull up CD desktop, CD CDIQ. Okay, and we'll look in here, and we're going to say xdg-open conversion 2. Alright, now we have to look here. Let's look. I hope you can see my cursor. If you can't, let me make it easier for you. We need to make this a lowercase y. Okay, we need to find the lowercase y, and it's right at the corner of my terminal, right here. Okay, not an uppercase y. There is a difference. The difference is 59 is the uppercase y, and 79 is the lowercase y. Okay, that's done. Can I exit this? Sure. Let me exit this too. Maybe not. Let me put it down here at the bottom. Okay. Sure thing. Okay. So, as you can remember, it was either yes or no. Now, it doesn't have to be a y. We can test it for n. Alright? But I chose y. Okay? Now, it is a lowercase y, though. It's not an uppercase I. And there is a difference. Okay? Hexadecimal. So, a lowercase y, as we said, was the number 79. Okay? So what's going to happen is we moved our string into there, okay, and then we dumped our string out, dumped the string location out, okay. Well, this is the dump out, okay. Initialized it, not initialized it, but we used the interrupt 21, okay. To what happened is this just fell out, okay, and when it fell out, what did it do? It said something, okay, and it asked you the question, do you like tacos, yes or no, okay. Then after that fell out, this said, move into the AH register, get ready for a key press, and show the key press. Okay? Or get input from the keyboard and show that input. Move that into the AH register. I'm going to stop saying initialized. That's not what it means. Okay? Or execute this previous instruction. Okay? And that's what it did. It took your key press of either if you typed in Y or no, it still took it. Okay, it still took yes, or it still took no. That does not matter. What does matter is it's going to compare what the file handler sent back. It's going to compare what is in the what the key press is. Okay, your key press went in here. It said prepare for key press in AH register, right? But preparing for key press and showing the string or showing the key press, it sent back a handler that landed over here. Okay, it sent back a value is what I want to say. Okay, this opcode sent back a value, and that value resides now in the AL register. Doesn't matter what the value is. Yes, no. It could be 129. It could have been oh my god. It could have been quit. Okay, it's going to compare whatever's in this register with the hexadecimal representation of the letter Y. Okay? And that hexadecimal representation of the letter Y is 79. So it's going to compare whatever you typed in with 79. Okay? Or Y. And then what we're going to do is, because this code does run in progression, top to bottom, then we're going to use a bunch of test statements. This is where the jumps come in. Jump is not what we're going to use, okay? But we're going to use jump if equal, okay? That's what JE stands for, jump if equal, okay? And we have to give it an address to jump to if equal. Where do I want to jump to? Address 160. It's gonna be kind of tight. Jump if equals. Let's jump if equal. If I go to 160, this is where I gotta use my gubernator. I'm gonna, let me just jump, see what happens. To hell with it. I can always make another video. But this is where precision, this is where I told you in the other tutorial, precision within like a tolerance of freaking 20 bytes really matters, right? Jump if equals, what you're going to do is you're going to jump to the address of 150. So like I said, after it gets your press, it's going to compare it with Y. Doesn't matter if you pressed Q or not. Q is not an option up top. But we didn't signify that it's not an option. It doesn't matter. What it's going to do is it's only going to compare it with Y. And if it equals Y, jump if equals Y, it's going to jump to 150, okay? And that address 150, the address 150 is going to be some more code on what to do. Now we have to say, what happens if it does not equal Y? If whatever you typed in, a Q, does not equal Y? Well, we have to then say something that is called jump not equal, okay? And if it's not equal, what we're going to do is we're going to jump to 170. Now, if that is not close, okay, we're going to jump to 170. And does it matter? It doesn't matter. It doesn't matter. That's tighter than a frog's ear hole. But it doesn't matter. Okay? So, like I said, it's going to compare it with Y. And if it is Y, if jump if equal to Y, it's going to go to 150. Alright? But if it's not equal to Y, it's going to jump to 170, which happens to be the next address. 171 happens to be the next address. Alright. Now, let me do something that is helpful and useful to see. Okay? I'm going to jump to 170. But this is at 171. And I am super paranoid. And I'm telling you right now, my gut instincts is telling me, my monkey senses is telling me that this is freaking wrong. Okay? So I can also move my assembler to another location, even if that location means that I overwrite exactly what I just put down. Okay? Move assembler to 016 alpha. Okay? So basically what I'm going to do is I just moved my assembler back up and I took away my error, my gubernator. I screwed that up. I want to jump higher than that, just by even a couple bytes. Okay? I screwed this up. So where I'm at now on my assembler is I moved the assembler back up to this position. Okay? So now I can fix it. Or actually, it's already fixed itself. It put it back at another, I don't want to say 0. It didn't put it at 0, but it put it at something that is not jump not equal to 170. Okay, so I want to say now jump not equal to 180. Okay? Okay. So that's that. And I'm cheating my butt off because I already did this code on my other DOS machine, and that's all I'm looking at. But I'm looking at in reverse, so I'm looking at the edit file. It would take me forever, as if my videos are not long enough. Okay, so remember that we did the compare statement, okay, and we're going to say jump to 150 if it was equal to, okay, we overwrote this. Look at our addresses, okay, our address, our first blooper got covered up by this blooper. This is where our new address is, okay. Let me say jump not equal to 180. Okay, so at these two locations, we have to continue some code. Alright? Super. Okay, so now let's go back into the assembler mode. Okay, and it was to say, assemble to address 150. Okay, that's our equal statement. Okay, and if our number stored in here, if our key press stored in here is equal to 79 or equals y, this is what we want to do. We want to print out the string yes. Okay, me too. Okay, so in order to do that, we have to get ready to put the string in. Okay, so we say move into AEH, we get a string coming. Okay, move into the DX register the physical string, or not physical string, but the address of the string, right? Right. And that is at 122. Okay, now look up here. Our opening message, our questioning message, it disappeared. Okay, now by luck we don't really need that anymore, but by luck we don't need it anymore. That's the importance of what I said, to make sure that we write down the address locations of what was there, because now you see that if we needed to go back and get anything up that high, it's gone. It's gone forever. You'll never find it ever again. You just threw it away. It's gone. Alright. Alright. So remember, at address 122, okay, we have our yes statement, which is me too, baby gangsta. Alright. So we need to move into the DX register that location, which is at 122. Okay, I think that's right. I've got a good feeling. Bang. Okay, now we moved our string, or we told our we prepared the AH register for a string. We moved the address location of the string in. Okay, and now we need to say int 21. Okay, we need to execute it, and what we need to do is exit the program as well. Okay? Okay. So that part is done. This statement is complete. This statement hopefully will work. We compared it with yes. Okay? And if it was yes, and maybe it is, well, it depends on what your key press is. Alright? It's going to jump to 150. So this is what is at address 150. Okay, at address 150, it's going to say move string, move, or get ready for string, move the address of the string into the DX register. Okay, execute this stuff above, stop program. Okay, okay. Now, I had something good to say and I forget what it was. Okay. Now let's do it if it's a no statement. As you can see, remember, our statements are just disappearing across the top. Our data bytes are gone. Alright? So that is a good reason to write this stuff down. Okay? Especially because, do you want to go back over this? I don't think so. This is hard. Harder. Okay? So now we want to assemble at address 180. Right? Right. Yeah, because we were at 170, we screwed it up. Let's go to 180. Now we want to say the no statement. At address 180, okay, we want to move into AH string 09, okay? And what string do we want to move in? We want to move in to the DX register, the address location of, look how close that is from being just going away forever. We want to move in this address location, which is at 142. Okay, we want to move in 142. That string is what we want to move in. Okay, let's say enter. Let's say int 20 to execute the above, int 20 to exit. Not int 20 to execute the above, but int 20 to int 21 to execute above, int 20 to exit. Okay, okay. So that's what we do. All right. Now let's go ahead and enter that. We're physically, well, really, we're done our program. Okay. Let's enter the debug mode again, and let's use a hex calculator on it. Where did we end up? We ended up at 189 bytes. Okay, or the address location 0189. So say 0189. It's not really important, but I do, to add the 01. Okay, you could just say 189. Let's do it anyway and see what happens. Why not? Okay, where did we start from? We started from 100. Okay, let's press enter. It does the math for us. Okay, takes out the blue. Alright, and we're left with 89 bytes. Okay, now let's say we're going to modify the contents of register CX. Okay, which should not hold anything at all. It's not. Alright, we'll modify RCX. Okay, and you can see it zeroed out, has nothing in it anyway. Alright, we're going to modify RCX, and we're going to add into it 89 bytes. 89 bytes in RCX. Okay? Now we will name it. Let's name it the question. The quest. Yes, let's make it mystical. The quest. Remember, we have to name it not .asm, but we have to name it a .com file for an executable file. .com. Okay? That's named. Now let's write it. Okay? You can see it wrote 89 bytes. Now let's quit. Clear? The quest. Are you ready? Are you ready for the quest? I hope this works. Now all we have to do is type in the, or you can hit tab, and thequest.com comes up. Let's see what happens. Ask us the question on the new line. Do you like tacos? Let's do a dumb thing and say no. And that says you're crazy. Alright? Now, where I messed up is I didn't put this on a new line, and I could have, but I didn't. Alright? I didn't know that I was going to mess that up. I was just so worried that this would not happen for me that I had to go all the way back up to 89 bytes a line. Alright? Now let's run it again. The quest. Do you like tacos? Say yes. Alright? And again, I did not put this on a new line. I don't think I did anyway. I don't know. Maybe I should rewind my own tutorial and look. But I don't think I did. Actually, I did. I think I know what I did wrong. I think I threw the question was here, okay? And then I threw an ODOA, okay? And what I should have done was, this new line thing, yeah, okay, it was there. It did print a new line, but it didn't print my message on a new line. What it should have did, what I should have done was put ODOA, okay, and then I should have gone ahead and put my my data, the question. Okay, I should have done that, and of course I ended up with a string terminator. Okay, I should have did that, and this would have put it out on a new line, so it wouldn't have been all jarbled up like it is here. And you know what? It doesn't matter that it's all jarbled up, because it works. Okay, let's do it. Uno mos centrifugo. One more time. Is what I meant to say. Do you like tacos? Alright? Yes. Okay? Now you can see that we have what we typed in was yes. Right? It doesn't say, why me too, baby gangster? It says, yes, me too, baby gangster. You know what I'm saying? Right. Now let's do it again, and we'll type it in no. Okay? And what happened was here, it showed our key press, which was N, okay, and it said, you're crazy. It didn't say, and you're crazy. You know, it's like, you know, do you like tacos? No. And you're crazy. You know what I'm saying? Alright? So that's what happened there. Now, let's say dir, and let's do debug. Let's debug the quest. Thequest.com. Actually, that sounds kind of weird. I don't like the quest. It sounds like unicorns and mystical castles and crap like that, and we're trying to be gangster, right? So let's just call it the question from now on. Let's dump it. Okay. This is funny. We dumped it. We dumped our source code file. No. The problem is, we never made a source code file. Okay? This is an executable right off the bat. We never made a source code file. What we did was we entered in stuff that got executed, right or wrong. So the moves and jumps are gone, but what is left are these data segments. 64 is hex for do or D, 6F is hex for O, 20 is hex for space, 79 is Y. Okay. So when we entered it, we didn't enter it in a source code format. We entered it straight into RAM. Straight into RAM. Alright? There was no source code. We just threw it right in the RAM. And that's exactly what I was trying to talk about. It's a good example. Okay? Now, why didn't the machine code come out? Why didn't we see the actual move command, move AH register, move into AL register, anything else like that? What is EB? Okay? EB, if by reason, let's say, if EB is a dot, okay, then why isn't this dot down here EB as well? Alright? Okay, and you'll see better what I'm trying to talk about when I do the calculator. Alright? EB cannot be a dot here, and OF cannot be a dot here. That doesn't happen. What it did was, this here is transformed into something, right? Transformed into something that is not read by the interpreter over here, or this computer does not read those things. The only thing that it does read is stuff here, okay? Or basically what I'm trying to say is, the hex value, let's clear this. No, let's not clear it. Let's just move it up. The hex value, okay, that is less than 20, okay, is a bunch of machine looking stuff. Okay? Okay. And why do I say less than 20? Well, the space bar, if I touch, yeah, here we go, thank God. The space bar is ASCII, or the space bar is ASCII, oh Jesus. The space bar's representation in hexadecimal, right, is what? 20. Okay? So anything below 20 is some machine type of crap. Okay? And it's good to see that. These tutorials are working out fine. Let me pull this up, and we can get an exact frame on what we're talking about. Let's go to, not here, let's go to this here. Okay? Super. Alright. We don't need this anymore. Everything worked out fine. Peace out, window. You've been great to us all. I should have played some music as it went away, right? Like, da, 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 whatever. Alright. No, that only facilitates our little the quest thing with unicorns and crap like that. We're gangsters. Right? Right. But we will use this as a pointer. Oh, no? No, okay. You say it shook it, no. That's why I love Lennox. Love you, baby. Alright. So, let's look here. We see the space bar is at number 20, right? Remember that this is hexadecimal to ASCII. Or, let's move it over here. Remember, this is hexadecimal to ASCII, so hexadecimal naturally comes first to ASCII, right? Right. The space bar is at number 20. 21 is the exclamation mark. 22 is the double quote, okay? But we're going in the wrong direction. Let's go down. Alright? 1F is US. What is that? I don't know what that is. Could I say RS or US is like for a signal code for United States? Maybe. I don't know. RS. What is RS? Can we say Russia? Sure. Why not? Okay. 1D is GS. What is GS? Great Samoa? I don't know. I don't know. 1B is the escape character. Okay. 1A is to subtract, or an instruction to subtract. Maybe? Maybe. Okay? But if that was the case, it sounds good that maybe 1A would be a subtract instruction, but where's the move instruction? Where's the jump instructions? Where is the jump not equal, jump compare, jump not zero instructions? Where are they? I don't see them. And they can't be anywhere but below number 20. Because if they were above number 20, well, they would be all up in our number range, and they would be all up in our letter range, and all that other stuff like that. And ASCII by nature cannot go above FF. I guess. Let's check that and make sure. 7F. I guess. I don't know. Where's those other instructions? Who knows? Maybe ASCII K can go up to FF. I don't see why I wouldn't be able to. But whatever. So, where are these other instructions? We don't know, and it's not important. What does DC1 mean? DC2, DC3, and 4? What do they mean? What's 15 mean? NAC. I don't know. Okay? This here, thank God, it shows us that 09 means HT, or tab. Why HT? I don't know why HT. Would it be hit tab? High tab? Pfft. Who knows? Backspace is 09 in hexadecimal. ASCII is BS, which is backspace. Okay? 07 is the bell. I heard you can ring the bell. I never rang my bell on my processor or on my motherboard. I've tried, and it sucks. Line feed is OA. Okay? Form feed. I don't know what that means. Line feed, I think, is return. No, I don't know what it is. I'm not even gonna lie to you. Return. Thank God I didn't say carriage return. Thank God I didn't say a line feed is carriage return, because down here you would have been like, oh, you're an idiot. Look, CR, carriage return, return. New line. Okay? Okay. So, as I said before, OA and OD. Remember? ODOA for our new line. Okay? OD is return. OA is our line feed, or I guess maybe a line. Okay, so I was right. Alright? But that's what we type in our stuff to signify a new line, when we type it in the right position. Right? Because the last one, I'm pretty sure we typed in ODOA, but we put it after the string, before the string. So the string popped out where it was supposed to be, and the new line went down with nothing there, and then terminated. So it went down like in a ball of fire. Alright? So, as I said before, and this will get a lot simpler to understand once I pull a calculator out on it, alright? Or show you how to make a calculator, because you'll notice that some numbers will dip below 20, and when it dips below 20, it's going to pull out these funky characters and this funky stuff here, and it's not going to spit it out like DLE, SI, SO. It's not going to spit out SOH or null. It's not going to spit that out what it's going to spit out is crazy crap like this, either dots or crazy less than, greater than signs. I mean, it's going to start spitting out stuff like that. Okay, now we don't need this anymore. Quit. I quit you. Clear. Yeah, I gotta make a clear program too. Or I want to show you how to make a clear program too. I already got it made, it's cool. Let's say debug dump anywhere. Alright? Look at this stuff here. Right? Percent these and everything else. Like, why do you think it looks like that? You know what I mean? Why do you think some of these things occur in here? Okay? All these things here can't be a dot. What are they? Okay? It's all characters that cannot be read by the attempt to interpret, the attempt to get the attempt to convert hex to ASCII. These dots just signify I can't read those, man. And really, if I could read them, why even read them? Okay, because they say stuff like, you know, stole and DC1 and DC whatever. You're not going to be able to understand that because you're a human being. Alright? There's no reason for you to actually read those. Or that could be machine code. Okay? Okay. So thank you very much for watching. Hope you like these videos. Let's see what's in my registers real quick. Okay. Hope you like these videos. And I would like to say too, for one, and I stress the file format again, how it's laying, how we're taking, like I said, a can of sardines and throwing it at the hard drive, and that question arises with Windows and the security of Windows, and we know that there's antiviruses. All Windows and systems need antiviruses and whatever like that. Blah, blah, blah. How Linux doesn't need, and blah, blah, blah. But what it is with the fundamentals of the operating system itself, the way that it writes to data. Because this is DOS. Yes, this is DOS. But guess what? DOS is built on, okay, and is in Windows 7. 8, slimmed down version, of course. But DOS uses, or Windows uses the command prompt. Equals command, right? As long as you have a command prompt, and as long as you have Windows's inability to fix things, you will have viruses and freaking direct gateways. Look at where we're at. We're at the machine code level. Alright? There is no problem for you to get an executable file, and Windows is too stupid, like a dog, just to say, oh, you got an executable? Yeah, sure, run the hell out of it. Run it where? Run it in the root of your freaking operating system, so you load malicious code right into RAM. And not only do you load it right into RAM, but come and just throw whatever's in RAM at the hard drive. Good, bad, indifferent, on fire, full of AIDS, whatever. That's the ideology behind Windows. That's why they have so many viruses. And the other thing is that this program here, DOS is not running as a user program. Okay? It's not running as a user service. Okay? This is running right now. This here, when we dump this out, we are looking at the direct contents of memory and everything else. Look. Don't look. Dump. We're looking at the direct contents of memory. Right now, even if, you know, if we screwed up and we said write, it would overwrite some crap. It would probably overwrite even the bootloader, operating system, whatever the hell, anywhere. In the bad area, it would rewrite it. And you would have a problem. Okay? You would have a serious problem. Let's go to data segment. How do we get there? Data dump. Let's say dump code segment 000. Oh, the right stuff. Alright? That's not what it was supposed to do. It was supposed to do something else. Dump data segment 000. Okay, because this is an emulator, it's not going to let me change the code segment here from 7OBE to quad O, right? Alright, so let's say what's in our registers. Where's our instruction pointer setting? Okay, let's change the contents of the code segment register to 0000, right? Oh, no, you're not going to let me, of course. Let's say CS, change RCS, okay? No, you're not going to let me. How about CS? Alright. The code segment now is pointed to 07BE. I want to go all the way down to nothing. Alright, enter. Let's dump out data segment 000 now. Of course it didn't change because it's just a freaking crappy operating system. You know what? It seldom changes on my MS-DOS desktop too, unless I restart it, which makes no sense. Okay? Or it'll change whenever it feels like it, probably in the next couple commands. Why did T terminate? I think it hurt us, dudes. Yeah. I think we've been a little too hard on her. What do you think? Yeah, it hurt us. I think it hurt us, dudes. Yeah. Listen, we're sorry that you're such a shitty operating system, but you gotta get your shit together. Okay? Let's say debug. Okay? Let's dump now. See where we are. By default, we're at 07BE. Let's change the contents of the code segment register. Okay? Where do you want to go? We're going to go all the way down to no. Okay? Now let's go ahead and we're going to dump code segment. The code segment we're going to dump is 0000. Bang. There we go. I think it restarted itself because it knew it was acting up. Alright? But when we change the code segment, look at where we are. We're somewhere. I don't know where we are. We were somewhere deep in the OS. Can we dump again? Let's dump again. Let's go up. Let's keep going. Let's keep going. Let's keep going. Sorry you gotta look at this stuff, but let's keep going and see exactly where we are in our operating system. We're running around in our operating system right now. Bang! Look at that. Debug.com. That not only is in RAM, but it's reading from something. Debug.com .0 45 whatever like that. This is a location somewhere in memory. Now, is all of memory being called up, or is the hard drive being called up? And these certain blocks are actually reading from the hard drive. I would choose to think it's from the hard drive, right or wrong. Dump. Let's dump again. Let's keep going. Let's find something like boot. Debug.bin.com. How does that sound, huh? Sounds like an executable somewhere that we're calling up in RAM that we just found on our hard drive somewhere. zcommand.com. Let's run it again. Keep it going. Keep it going. Bang. ODR. This could go on forever. And it would be better for you to probably experiment by yourself and me not to do a tutorial about this. But I would like to show you how vulnerable your operating system is to things. DOS EMU. Whatever. Alright? We were just reading from an emulator anyway, so it doesn't matter. You're right. What happens when you read this on a physical machine? What kind of emulator are you reading from then? Alright? You're not reading from an emulator, you're reading from your hard drive. Your hard drive, you're calling up your whole hard drive to put it into memory. Okay? And once it's up in memory, all you have to do is say something like write. Okay? Write. Name it. Let's say RCX. Right? Sure. RCX. Register CX. And we want to write 999 bytes. Okay? And what we want to call it? AIDS. Let's write AIDS. Bang. There you go. Alright? Your hard drive has AIDS. Your operating system facilitated that for you. Good old Billy Gates. So. I said I wasn't going to rant. But I like people to see how vulnerable their systems are because of stupid shit. Alright? It shouldn't be this way. If they came in and they did a couple things and didn't build on sand, then these things could have been fixed. But this is why you have so many antiviruses. This is why Windows is just an unstable environment to even do anything in, and is very dangerous, especially if you don't want to be exploited and have your data stolen and be held in fear that you have to upgrade your freaking antivirus every 30 days or pay $399 for another one. Right? I feel like we're getting closer during these rants. I'm gonna get some popcorn now. But you guys have a great day. Sudo su ps aux, and I will catch you later. 10:40